right. So for the interest of time, or thank you so much everyone for joining us today. I am Sheila from Octane, and I am the Senior Sales Executive. And thank you all for joining today's session. So today's session will be led by Madhur, a seasoned expert in IBM Planning Analytics who has been actively advocating IBM products and ecosystem solutions for the past 15 years. So over the years, he's worked across multiple regions and continents, especially in India and Middle East. And also, he's very successful in helping enterprise customers drive large-scale digital transformation initiatives through his expertise in planning analytics and also business process modernization. So with that, I would now like to hand over this session to him to share his insights on today's topic. So reimagining sales and operations planning in manufacturing. So over to you, Madhur.
Thank you. Thank you so much, Sheila. Uh, Good morning, everyone, and good afternoon too. Uh, so today's session is called as reimagining the sales and operational planning in the manufacturing. It's going to be around 45 minutes to 60 minutes of practical walkthrough on IBM Planning Analytics. A quick word about me. Sheila already discussed and explained about my achievements and things like that. So I'm Madhur. I'm a practice lead at Octane. I've spent around 15 plus years around the ecosystem of IBM, around the business analytics and the product like IBM Planning Analytics, Cognos Controller, Ciplex, and so on. I've worked across the multiple domains, including the manufacturing, FMCG, the industrial sectors. uh, Today's format is going to be very simple. It's more about me to set the context, and then I'll take you around the 35 minutes of live session. It's going to be a walkthrough on the platform, and you know, uh, last few minutes for your questions and so on, right? So, um, so before I kind of move to the next slide, right? So I want to spend not more than 3 to 4 minutes, and I want to give you um, the idea about or the mindset about why this topic matters right now. Right, there are four forces which are reshaping the manufacturing planning perspective today. Right, the first is volatility, um, and that volatility itself is a new baseline. The demand swings that used to be a quarterly now happening at monthly and even sometimes at a weekly level. Raw material prices are moving faster than the planning cycles can react to it. Second, the supply chain stays fragile. The single source model broke during the COVID, and then even the geopolitical the tensions recently that which we all of us have noticed, right? Uh, and they have not yet fully recovered. So lead time is still permanent issue, I would say. Uh, and third is the decisions must move faster. The leadership now expect the quarterly decisions, monthly decisions now at a weekly, and 6 week S&OP cycles cannot give everything up, right? And fourth is the cross-functional visibility is still missing. The demand, production, procurement, and finance plan is still isolated. The trade-offs have become more visible only after the margin is missed. The bottom line is the planning models designed for stability cannot survive this kind of within this volatility, and this is the S&OP gap as on today. Now, so let's understand where the disconnect is, right? So I want to anchor today's session on the challenges today is not just about the lack of the data. It is more about the connecting different decisions. So most of the manufacturers have more planning data than they try to have it ever, right? So ERP, then retailers pay, the supplies portal, the finance system, the data is there. What is missing is connectivity between those decisions. On the left side, if you can see, the traditional S&OP looks like today, right? Demand sits in the sales spreadsheet, the production and procurement work on a different numbers, the finance arrives only at a month end. Scenario analysis takes weeks of time for them to identify which is the best one to go with. On the right hand side, what is what is integrated business planning looks like. So one connected model, statistical baseline plus driver-based overlays, operational scenarios flowing live into the PNL and what if in seconds and not in really in weeks, right? The shift from left to right, that is the shift that we are going to walk you through today, right? So six questions, right? These are the six questions I hear from manufacturing leadership team. The question that most planning environments today cannot answer in 24 hours. One is demand surge. If the demand rises by 15%, can our plans deliver it? If raw material prices rises by 8%, what happens to our margin? Can we survive with the additional retail demand without locking up more cash? If lead time doubles, where does our line stop first? What is the P&L impact on the promotions before we kind of go and approve it, or could be a discounting, right? Which plant should produce the additional volume at what cost and at what margin? So keep these six questions in mind. Every skin we look at the next 35 minutes or 45 minutes are going to answer all of them, right? So the today's session, what we are going to cover is next 45 minutes, right? So demand signal creation. We will see how statistical baseline is built and then how it has been layered with the business drivers and trade promotions, planning, and things like that. Operational translation, we will convert the demand into a feasibility operational plan and material, bill of material and production allocation, supplies, and then inventory. The financial reconciliation, which is the key. Every operational layer would kind of flow into the P&L, ending with the integrated business planning view. And then we will kind of, close the session with your questions, of course, right? So with that note, let me, take you the model and let's start that, right? So let me just switch over the screen. Well, so today's session is intentionally not a product pitch. What I want to do is walk you through a practical S&OP framework, and we have built it on IBM Planning Analytics. And I'm going to show you how the different planning layers can be worked together inside one single connected model. We will start with the demand forecasting, move into the demand, shaping, then translate that demand into the bill of material costing, production allocation across those plants, then supplier planning, inventory, then material requirement planning, what we call it as a MRP. Then finally, we will close with the financial impact and the integrated business view. Throughout the session, I'll be also be sharing some of the practical implementation realities, right? Most, I mean, of course, those are from the different experiences that we have gained till now from the manufacturing organizations who struggle with the particular, the particularly around the planner adoptions or the usability and simplifying the large planning templates so that they are actually, get used. So what I'm going to do is I'm just going to take you through those different blogs and things like that. So as you know, this is the planning analytics from the user experience that comes with, right? So this is the model that we have. So before we kind of look at chart, if you kind of notice something on top of the screen, right? So you can see the series of drop downs here. So like the planning versions and then the finished products that we have, the customers could be the country and then the channel. This may look kind of trivial, but in a real implementation, this is one of the most critical design decisions because in a large manufacturing organizations, you may have thousands or 4,000 or even sometimes in 15,000 SKUs, 50 customers, 8 plants, or maybe 15 plants, and have the multiple sales channels. This is millions of planning intersections. If you put all of them in front of the demand layer, they will simply not use the system. Adoption dies in a big circle, right? So the principle we follow is the model in the back end can be, very much anonymous, but the view a planner interact with should feel like, there are 20 to 30 relevant tools. The filtering, by their different product families and geography channels and the seasonality, the relationship and then, the responsibility. This is something that we have taken to do, right? But then what we have is this system focus, which is statistical focus. So what we are looking at here is a system generated forecast. The purple line here, right? It is the baseline forecast, and the red and orange lines are the upper and lower confidence interval, the band within which we statistically expect the demand or the actual demand to fall. Now, I want to be very clear about what's this and what this is going to help you out. This is not mean to replace a planner judgment. The objective is to create a neutral starting point, a common baseline, because historically, one of the biggest source of the friction in sales and operational meeting is the sales works with the one number, right? Marketing has another number, finance has the third number, and the operation doesn't trust any of them. When you start with the statistical baseline, everybody that everybody can see was generated the same way, the conversation changes, right? Instead of debating on the opinions, teams debate on the variance against a common baseline. This is a fundamentally different and far more productive conversation. So behind the curve, time series model uh, is what we have implemented, and our implementation picks up the best fit algorithm for from our library, the Hall printers and Arima exponential smoothing, depending upon the demand patterns of the SQs and seasonal SQs, that we get from the model, right? Now, what we have is the demand, the historical demand, I would say, right? So, so below this particular, the chart, it gives it more information about how the historically by month different units looking like, right? Those are the actual seasonality. So what I'm going to do is I'm just simply going to make use of the univariate forecasting, which is a key when it comes to the forecasting, and it has got multiple algorithms. So we have done, our setup accordingly. We have made the use of the exploration data, so some of the upper bound and lower bound that you can definitely be able to define. Some of the spreading options definitely, as end user would be able to define it. And what I'm going to do is that, I'm just going to simply do a forecasting. And the moment I click on the forecasting, my whole, the parameters in terms of my demand generations and things like that is going to get changed, right? Now, once let's understand, right? So, uh, the idea here is to make a use of the inbuilt functionality of IBM Planning Analytics and not to integrate with the different, the Python-based scripting or Python-based statistical models. So here you can go and look at the demand, though you have historical data by a month for the projections for end user to get the view on it. However, you can fetch it directly from the underlying databases, and you can have the forecasting been done on the on the weekly basis as right. So so that the system focus, right? So statistically generated baseline is what we have produced here. But in reality, demand is never purely a statistical. Business events continuously influence the demand, promotions, pricing changes, distributor incentives, competitors' action. So let me show how we can layer the business intelligence on top of this baseline, right? So let me just go to the demand, which is this is where we are going to do the adjustment and things like that, right? What you're saying here uh, is the business intelligence layer, I would say. Right? The statistical focus is the bottom of the whole pyramid. On top of that, now we are applying some commercial drivers. Uh, Commercial drivers means the things that changes your demand for the reason the statistical models cannot see. Look at the driver settings here, right? So we have set the year-on-year growth over, for the several by percentages. The commercial team expect, there are going to be some sort of the downlift as well. Perhaps, the distributor expansion or the new listing or the category growth in this particular geographical may have some kind of exceptions, right? So also the interest rate is something which is going to drive this whole model, meaning we are actively activating the macroeconomic sensitivity for the customer goods. And this matters because the consumer spending power is the interest rate sensitivity in this particular the market, right? Then what we have is something around uh, the interest rates, and then the trade promotions, right? So we have the trade promotion planning panel as well. This is where the commercials and the trade marketing team plugs their promotional intent. So you can see we have the default discount of 2% all quarters, right? Um, and this is the baseline trade discount, and then then of course, based on this, you may have different adjustments based on the seasonality and things like that. Now, let's understand why this is very important, right? Because most of the manufacturing organizations, particularly in FMCG, food and consumer health, right, trade promotions are the single largest demand, uh, uh, which swing the whole factor, right? And in the most of the organizations, they are also the least integrated into the operational plan. The trade marketer commits a promotion to a retailer, and then operations find out about uh, through a forwarded email 2 weeks later and things like that, right? So those are the critical aspects which comes in. Then what we have is the the slab achievements. So here it is more interesting. The slab achievement, this is the contract structure with the retailer. The more we sell, higher this discount slabs that kicks in. The slab one is up to, say, for example, 155K units per quarter at 1% of discount. Slab 5 kicks off, with the 175K units at 4.5, the percentages and things like that. So now the model has to do something quite sophisticated here, right? Meaning, um, it has to predict which slabs will land in each particular quarter and apply the right discount to the net revenue accordingly. So with this kind of detail, most of the planning processes uh, lies only the inside the head of one of the key account manager. So here it is structured and transparent and auditable to everyone. Right. Now, let me just look at the data points which we have already figured that the data has been pushed here, um, and then let me just refresh this. Okay. So this table is essentially the demand waterfall, and I want to walk you through slowly because every row tells a different story altogether. So baseline, so I'll just go by each of those. So baseline system, the Q1 for 2026, right? You can see 169K unit. This is a straight from the statistical forecast that we already performed using the unified forecasting. Doesn't really require any sort of human interventions, right? The second row is the baseline driver base. So Q1 jumps from uh, to the 162 468, right? That's the difference about some of the units is the commercial team's growth assumptions. Well, I mean, of course, those are flowing through
You
some
did
of
record.
the assumptions that we have done, right? Now, let's understand what is the baseline manual adjustments. Currently, though it is zero, right? But this is where the planner can plug in the manual overrides if they have the local intelligence. Uh, uh, I mean, the drivers don't capture it, right? And then what we have is the baseline selection answer. Now, this is the version for the planner which he has chosen to work with. So here we have, already mentioned that we are going to use the baseline as a system generated and not the manual ones. Then we have applied, say, interest impacts, then, the discount promotions and things like that. So on a single screen, the planner has moved from the statistically the X number and commercially loaded the X number. And crucially, every step is a kind of a traceable, right? And at last, what we have is the visual impact of these three layers together. The purple line here is the statistical baseline. Orange line is the final trade promotion demand. And what is the that is what the operationally or the operations actually need to plan against. The notice the spike in this in the the month of, I think this is the month of uh, uh I think April, right? So August and September. So this is the This is because of the seasonal promotions which are combined with the slab that we have been achieved. If the operation was planning in the the purple line, they would underproduce by 10 to 12% in the period and miss the retailer committee, right? So now let me just take you to the one of the critical aspect, which is the bill of material, right? So notice at the top we have selected Auckland as one of the plan, the work center as work center one, and the production line as well, right? Uh, and the Pack Pro Malaysia is a supplier of the packing the components. This matters because the BOM costs can vary by sourcing locations, plant, and same product and different cost profile. So the model is not making the simplifying assumptions that the product has one fixed cost. It calculates the cost dynamically based on where we make it and where we source it from. This becomes critical when we get into multi-plant production decisions later. So let's look at the quantity per finished unit. So here is a recipe, the bill of material. To produce 250 ml of bottle of shampoo, we have or basically we need 0.26 units of base shampoo liquid, 0.002 units of the fragrance oil, and small dose of the uh, the colorant, and one bottle and then one cap and nozzle and whatnot, right? So notice this is a quarterly granularity. Why? Because in real production, formulation can change, across the years. The winter formulation versus summer formulations, regulatory changes, raw material substitutions. During the shortage, the model is flexible enough to kind of accommodate, right? So, so the purchase price component is something which is the next bit which comes here, right? Again, why this is monthly? Because commonly, um, and it has been observed, the commodity link material, uh, the prices fluctuates every month. So if our base shampoo liquid is partially crude derived, the price moves with the petrochemicals
I can record
indices
sound.
as well, right?
I can record the
Then,
sound.
then let's understand the cost
But I
breakdown.
can't hear when I turn on recording.
I'm sorry, but someone has to really go on mute. So here, all it comes through and
What?
the actual landed cost per unit and things like that,
Oops.
right? So so for the different the time horizons, the total cost is maybe
Okay.
uh, uh,
Yeah.
for the X percentages and the material costs and things like that. What does the granularity visibility matters is because the moment you see one input, the base liquid is, say, for example, 62% of the total cost, the procurement strategy changes. You don't really have to run on the RFQs or the caps. You can run the RFQs on the base liquid. You don't really hedge the bottles, right? You hedge the chemistry behind the base. Then what we have is the warm costing bar chart. Now this is visually gets you the more understanding about the base shampoo liquid that basically uh, tops the everything else. That single visual in a procurement review ends the argument about where the strategic the focus should sit, right? So now let me take you to the work center related and the production related capacity planning, right? So the biggest operational challenge in the manufacturing is not just demand. It is I would say more the production synchronization because demand may look attractive commercially, but the operations team still has to answer which plant, which line, which shift, and at which particular price point or cost, right? So this is what this is what the screen is built for. So here we have, so if you look at the rate data entry, right? Here we have the cost rate per per minute per I would say minutes of a production, uh, the machine rate, labor rate, overhead rate, and they can vary by a different plan, by quarters, by labor environments and things like that. Let's understand the mechanism behind that or mindset behind it. Why this is very important? Because the cost of the production or producing the same SKU in Sydney is not the same as producing in Auckland, right? Or maybe in Malaysia. The energy cost differs, overhead absorption cost differs. So the model maintains these rates as a planning input, and the unit production cost recalculates everywhere you change the production location, right? Now what we have is the operational data entry. Now this table in the manufacturing, uh, uh, what we called as a routing as, right? The operation needs to produce one unit and then machine time, and then labor time for each. So mixing takes, say, for example, 0.004 machine minutes, filling 0.006 minutes, and capping and so on and so forth. This is by a different operations or the different processes that you have. Now, all those combines with the red table, and then you will get the routing cost per unit, roughly around 2% per unit, which is what we saw earlier in a BOM cost breakdown as well. This level of details, which enables something very powerful. It helps you do what if analysis on the operational improvements, saying that, if we kind of invest in automation, that cuts the filling time from, 0.006 to 0.004 minutes. What is the unit cost impact? What is the payback period for that? So those sort of critical decisions can be taken. Then let's understand the production capacity planning as well. So now here is the most strategic interesting screen. This is the production allocation across your network of plants. So today we are allocating around 55% of the production to Sydney and 50 or 45% of the production to the Auckland, right? And then different other plants too. But they are kept at zero at the moment. They have capability, but they're currently inactive for this particular SKUs, I would say. Now think about uh, what this means. If the planner can simply change this percentage, they can simulate the sourcing strategy as well in real time. What if we moved 10% of the Sydney production to the plant in Malaysia, right? Which mean what is the cost impact, capacity relief, the lead time impact, and gross margin impact? In traditional planning environment, this kind of network optimization is quarterly exercise done by a small central team using separate optimization tool like Gorobi and things like that. Here it is a part of every monthly S&OP review. So you can keep on tracking each and every week. Now let's understand the production ratio. So this is going one level deeper, I would say. Within each plant, we can allocate the production across the work centers. Today, we load uh, the load balance is the 50-50 between the center one and center two, right? This is where you can run the balancing scenario. If the center one is going down for a maintenance, maybe in the month of May, right? Can center two absorb the 100% of the volume? The, the model tells you immediately whether you have the capacity, headroom, or whether you need to bring work center three, so that you achieve what is desired to get. And then the capacity constraint. Sydney can do a production of, say, for example, around 100 K units per month. Auckland can do around 45 K. Uh, and then, there are some zero been allocated to the rest of the plant for this particular SKU. So even though physically the plant exists, they are not qualified or set up or set up for this particular product average. This is the constant that closes the whole loop because if our demand for August is maybe 78K, which we saw earlier, and our combined active capacity is 145 or 145K, right? We are comfortable. But if the demand spikes it, say around 160K unit, uh, so what would happen, right? So now Sydney and Auckland combines cannot deliver together. The system flags it, and then we either qualify, the other plan to come in, or we run overtime, or we do, commit on the, or basically we reduce or go down on the demand, right? Then, then the critical part comes is the supply planning. So we are looking at a specific component here, right? Uh, so component is one of the PK 003 water 250 ml, right? We have selected this one because the packing components are typically the most lead time sensitive and are at least for the consumer goods, I would say. If your bottle does not arrive, your line stops and there are no substitutes for it, right? So let's understand what are those supply constraints are. So we have three supplies for this particular one. Look at those, the different Malaysia, Singapore, and Australia based, different suppliers, and they have their own minimum order quantity and the lead time as well, which is based on the agreement that we have. Now, in the traditional procurement, uh, uh, you know, you would pick up one, usually the cheapest one, right? But in resilient supply chain one, you would actually manage all of those three. The cheapest supplier for the steady demand and the fastest for the emergency top-ups, and the local ones are the last mile insurance kind of thing, right? But the one of the biggest operational useful view in the entire model is basically the purchase content, right? For every supplier, every week we are tracking uh, uh, the three numbers. One is what has been allocated. That is what has been model says that you should buy from this particular supplier based on, and this is based on our sourcing strategies and constraint. Ordered is what we have actually ordered and place order with POs. And delivered quantity is what we have physically been arrived to our location. So notice in a week 5, right? Uh, the ProPack Malaysia is only allocated, the X units, and but ordered is 8,000 units. So because of the um, some of the constant that we have, the forced with the system has rounded them up with the minimum order. This kind of operational reality is exactly what the spreadsheet planning uh, really misses across, right? And then what we have is the product selling price. So and just to close the loop on the price side, the selling price is the uh, price to the Walmart, right? Is the 99 or 99 cents per unit, and that is across the year. So, so remember the cost that really factors or that basically drives the whole model is something which is basically product selling price, right? Now, let me go to the inventory side. Now, inventory is the most misunderstood lines on the balance sheet, right? Carry too much and your working capital is locked up. Uh,
You are
that is
not
the
sharing the slide. I got you. Sorry. Yeah.
uh, Sheila, is my screen visible?
That's not her.
Yeah,
It's visible.
All right. Inventory is one of the most, I would say, misunderstood line on the balance sheet, actually, right? So it carries too much of uh, your working capital, or basically too much of cost, and the working capital is being locked. That is a cash that cannot fund growth, right? And carry too little, and you miss the service levels, and you anger the retailers, you lose the shelf space as well. So the inventory planning is fundamentally a balancing exercise between the service risk and cash. The objective is not to maximize on the inventory, it is to maximize planning confidence with the optimal inventory, right? The product inventory table from the finished good perspective, if you look at, this is the weekly inventory engine for the finished goods, right? So we open the week with 148, the units, say for example, or for I think for one of the uh, I would say I will take the one of the parameter here. So so the opening inventory from which is coming from the previous, the month is 112. Demand is something that we have already driven. Safety stock is we have kept it as a 5% on the overall the stock that we have. And then this is what is your net requirement is, right? But let's understand from the monthly material requirement planning perspective, right? So this is where you're going to have the whole inventory mechanism being captured from the inventory, uh, closing inventory plus the net requirements that you have, including your demand and safety, and then what is your pure delivered quantity as well. This mechanism is going to give you the realistic view, not just from the balance sheet perspective, but also from the overall functionality perspective. One of the historical weakness of a traditional S&OP process has been a disconnect between the operations and finance, and that is where this KPIs can plays a vital role. The operational team optimizes the production, the finance team optimizes the profitability, and they are more concerned towards the costing side and maximization of profit. And very often, both teams are working on completely different planning assumptions. This screen exists to kind of to close this particular gap. Every operational decisions we look at is like the demand, the cost, capacity, supply, whole translate directly into the numbers you see here. So for this particular, for example, the SQ, which is FG1001, right? So so this particular XU, the SKU, you can see the different, the demand, different revenue streams by a different, the channels and by different the plant location and things like that. And those single view of the KPI would give a management a more practical scenario and more confidence on the overall S&OP model. And that is what is very important at the moment, I would say. So this is where the whole story comes together, and then what we get is the integrated business planning model. So at the top, you have the gross margin, and then the different parameters, including the net revenue, which starts from the gross revenue. Then we subtract the trade promotion, discounts, slab, and then we derive or come at the bottom line, right? Which is basically what is your whole integrated the cost looking like, including the different uh, the impacting figures as well, right? So every number on the screen is connected and it's a real time to every operational layer we have looked into from last 30 minutes or 45 minutes. So what are the driving factors this? The change, the demand growth, this particular screen is going to change because the raw material prices are going to change according to the whole mechanism of your suppliers and pricing and then promotions are going to change. We are going to change the plant allocation. That's going to change my whole mechanism of integrated business planning. This is what the integrated business planning model. Uh, and not just the having the overall dashboards getting refreshed, right? So so with this note, what I'll do is I'll just open up the the I would say the session for more Q&As and understand if you really have any questions around the overall model mechanism. And happy to kind of have one-on-one call as well, um, for someone who is really keen to know what exactly this model is going to deliver to them. What are the different aspects or the components that we have integrated with, and probably then we can get into a more deep dive session as well. So what you can do is you can just scan my QR code. You can book a one-on-one meeting. I'm happy to get into a call for 30 minutes and give you the exact industry specific detailing about what are those models are, uh, what are your current problem statements are, how we are going to nourish them, how we are going to resolve them using the integrated business model component. Also, I'll be happy to discuss about the implementation pricing and things like that.